Hi there, so today we're going to talk about Americium. It was long believed that there were only 92 natural elements, but it has since been discovered that neptunium and plutonium exist in nature in trace amounts. Americium, however, is entirely synthetic. It's extremely radioactive. Americium 241 has a half-life of 432 years. By comparison, uranium 238 has a half-life of 4.5 billion years. Though it's highly radioactive, you almost certainly have some in your bedroom. In addition to talking about Americium, I'm going to answer a few other things for the purposes of this video so that you understand what I'm talking about. That is, what radioactivity actually is, what half-life is, and what I mean when I say things like Americium 241 or uranium 238. The atomic number of an element refers to the number of protons it has. Hydrogen has 1 proton, so it's atomic number 1. Gold has 79, so it's atomic number 79. However, elements can have a differing number of neutrons. Hydrogen atoms with 0 neutrons are called protium. This is the most common form by far. Hydrogen atoms with 1 neutron are called deuterium. Hydrogen atoms with 2 neutrons are called tritium. Tritium is radioactive. These are called different isotopes, hydrogen 1, hydrogen 2, and so on. Hydrogen 2 means the sum of the protons and neutrons is 2. Neutrons are ever so slightly lighter than protons. If there's too much of an imbalance between the neutrons and the protons, the atom becomes unstable and breaks down to a different element. It's much more complicated than that, but this is the basic idea. The heavier the element, the more likely it is there'll be no number of neutrons that will cause the atoms to be stable. The heaviest element to have a stable atom is lead, atomic number 82. Bismuth 209 is technically radioactive, though it will take over 20 quintillion years for half of those atoms to decay, so don't worry, Pepto-Bismol won't give you thallium poisoning. Everything after that, starting with polonium, is indisputably radioactive. Scientists hope they will be able to synthesize an element in the future that will actually be stable, but that has not happened yet. Radioactive decay gives off energy. There are different types of decay, but I'm not really going to get into that here. This energy can be harnessed, which is how nuclear power plants work. As I alluded to previously, the half-life of something means that on average half of its atoms will decay in that much time. Americium 241 has a half-life of 432 years. It is thus over 10 million times as radioactive as uranium 238. So anyway, Americium, it is the 95th element in the periodic table, and it is entirely synthetic, probably. There might be a few stray atoms here and there, but that's about it. It is an actinide. It melts at 2,149 degrees Fahrenheit. It boils at 3,652 degrees Fahrenheit. It was first created in a lab in 1944, where plutonium-239 was bombarded with neutrons until it eventually became plutonium-240, then plutonium-241, and then it beta-decayed into americium-241. I mentioned that you almost certainly have some americium in your bedroom. You probably have some in your kitchen, too. That's because it is in smoke detectors. There's a chamber with a microscopic amount of americium. It shoots alpha particles, which are basically helium atoms, at a sensor. That sensor senses a disruption, it goes off. Smoke will cause a disruption. Alpha particles cannot cross the skin or even a piece of paper, and they're only harmful if ingested, so your smoke alarm is completely safe. Beyond that, americium has limited uses. It could be used in spacecraft batteries at some point. It is used by researchers as a source of neutrons and to produce heavier elements. It is also produced as nuclear waste and as a byproduct of atomic bombs. It has been used as a source of alpha particles and gamma rays as well. While it's entirely safe in a smoke detector, if ingested, it will kill you, so don't do that. Also, don't think you can make a nuclear bomb with a few smoke detectors. It doesn't really work like that. There's very, very, very little americium in one. You would need billions if you were going to try to do anything like that with it, so don't. It was named americium because it is right below europium on the periodic table, europium being a lanthanide, the actinides being right below that. It's also discovered in America by, among other people, Glenn T. Seaborg, who has an element named after him. Radioactivity is fascinating to me, and it's even more fascinating that something so feared is in everybody's home, and they have no clue about it. I think that's pretty cool. Thanks for watching this video. Take care.